This is called Mario and the Hole in the Sky, How a Chemist Saved Our Planet. And I really like this one because I'm a chemist, so I'm super excited about the chemist being the hero. All right. Let's get to the beginning. Mario Molina was born in Mexico City on March 19th, 1943. By the time he was 6, the world was awash in amazing new products made from amazing new chemicals. Spray. Mario's mother misted perfume onto her wrist. Squirt, squirt. Someone polished a window. Spurt, spurt. A press of a button propelled cleaner onto a counter, paint onto a fence, and hairspray onto curls. But one of the new chemicals used in millions of spray cans and refrigerators had a dangerous side that no one had yet discovered. Feliz cumpleaños, Mario.
What does that mean?
That means happy birthday, Mario. On Mario's 8th birthday, his parents gave him a microscope. Ooh, do we have a microscope in our house?
No.
Yeah, we do. Mario peered through the lens at a drop of water. Boring, he thought. Then he began to wonder, what would happen if I looked at dirty water? That's a pretty good question. Mario soaked some lettuce and let it rot. After a few days, the gooey, brownish green mess smelled awful. Blech. Mario plugged his nose, sucked up a dropper of the filthy water, and dripped it onto a slide. He peered into the lens and gasped. Incredible. All these amazing creatures in just one drop of water. It means incredible. There's so many creatures, and it's true. If you look at dirty water, you find all kinds of things. The first one to do that, the first person to make a microscope, was absolutely fascinated and revolutionized science, and now Mario found out as well. Mario studied everything he could under the microscope. Sparkling salt crystals, tomatoes, onions, chilies from salsa, even toothpaste. Mario was itching to see more.
Toothpaste?
Yeah. What do you think toothpaste looks like? Can I use this bathroom as a laboratory? He asked his parents. No one ever uses it. Dios mío, his mother groaned. Sounds messy. But they removed. Oh my gosh.
What does that?
It means oh my gosh. But they removed everything, removed the toilet for him, and installed some shelves. Don't blow anything up, his father warned. Clink, clink, shh, whoosh. Bitter-smelling smoke wafted out from under the door of Mario's bathroom lab. What are you up to, Mario? Asked his Aunt Esther, who was a chemist. Look at this, Tia. That means auntie. He showed her what scorched detergent looked like on a slide. She smiled and said, I think you need a few more things. She brought him a Bunsen burner and chemicals not found in a kid's chemistry set. Oh, she had the good stuff. Mario carefully mixed potions in his bathroom lab. Miraculously, substances changed from black to yellow, from water-soluble to waterproof. He conducted more experiments with a chemistry teacher in boarding school in Switzerland. He burned chemicals over the flames of Bunsen burners. Sparks flashed purple pink, crimson red, and green blue like fireworks, and each one of those colors means something. Look at all of those chemical structures in there. To Mario, chemistry had a mysterious power, a power that was changing the world around him. Stores were full of new and improved products featuring remarkable new ingredients that promised to be cheaper, better, faster. But Mario knew that even chemicals that seemed harmless could react with things in the environment and become dangerous. As Mario continued his study of chemistry, the question nagged him. Were these new chemicals really safe? What do you think?
Yes.
Are chemicals bad just because they're chemicals?
No.
No, but can they be?
Yes.
Yeah, so it's important to understand the chemicals, isn't it? Soon after getting his PhD and beginning work in the United States, Mario heard something that started him on a quest to find out. A scientist studying air samples found tiny amounts of chlorofluorocarbons, or CFCs, floating around in the air. Mario knew CFCs were used in refrigerators, air conditioners, insulation, and fast food containers, and as a propellant in millions of spray cans. He and his colleague, F. Sherwood Rowland, wondered, when CFCs were sprayed into the air or leaked out at the dump, what happened to them? Mario and Sherry set up a bunch of experiments to find out. You think they're going to figure it out? Hey! Uh-oh. They mixed CFCs with water. Most chemical compounds dissolve in rain, but the CFCs didn't dissolve. They shone lights on CFCs. Some chemical compounds break down when light shines on them, but the CFCs didn't break down. They set up a contraption to mimic Earth's lower atmosphere when any surviving chemical compounds usually decompose. But still, the CFCs endured. Oh my gosh, that's a lot of chemistry. In the upper atmosphere, a layer of ozone surrounds our planet. Like powerful sunscreen, the ozone layer filters out deadly solar radiation. That's a good thing, right? It's good. It keeps us protected from the sun. We have a lot less radiation because of the ozone layer. Like a powerful sunscreen, the ozone layer filters out deadly solar radiation known as ultraviolet light. What would happen if CFCs reached the ozone layer? Mario asked. To answer the question, Mario grabbed the simplest tools of a chemist, a pencil and paper. So you don't have to have all the fancy lab stuff. You can do it on pencil and paper first. He jotted down the ingredients that could be released if radiation broke down CFCs. Carbon, called C, fluorine, called F, chlorine, called Cl. Look at that. There it goes, the CFC coming out, and it could break down and release a chlorine, and the chlorine could get in contact with the oxygens. So up there, up in that ozone layer, there's a lot of oxygen running around, and the chlorine can break that up. Uh-oh. Then he wrote down what would happen if these ingredients reacted with oxygen, called O, in ozone, or O3. Mario discovered something scary. Chlorine floating around, freed by radiation, would break up ozone. That's terrifying. That's terrifying. Oh no. Bent over his chemical equations, Mario felt a huge weight pressing on him. The problem was even worse. After the chlorine destroyed the ozone, the chlorine survived. It could float around and destroy more and more ozone. Just one atom of chlorine could knock out tens of thousands of molecules of ozone. We need those ozone. Without ozone, deadly solar radiation would bombard Earth, killing all plant and animal life. Mario hurried to Sherry's office. We have a problem, a serious problem, and we have to do something. Look, there he is he's telling Sherry about it. He says, floating oxygen frees chlorine again. Freed chlorine moves on to destroy more ozone. Mario and Sherry faced a sea of TV and news reporters. CFCs used in millions of products are destroying our ozone layer, they said. They tried to explain the chemistry behind it, but only a few news reporters followed, and none captured the magnitude of the crisis. See, that's why it's so important for everybody to understand a little bit of chemistry, just enough to follow along with the scientists. Mario tried again. He told Congress that CFCs were destroying the ozone layer. Still, no one took action. No one seemed to understand how serious the problem was. Mario was aghast. People believed it was just impossible that humankind could endanger the entire planet. No way. The planet was big enough, it would just take care of itself, he says. But I knew this wasn't true, so he kept trying. A load of rubbish. It's a science fiction tale. Utter nonsense. That sounds like things that people say when they don't want to understand the truth, doesn't it? For more than 10 years, Mario continued to study the problem and warn people about the danger. If we keep using CFCs, he said, huge chunks of the ozone layer will thin or disappear. Skin cancer and eye disease could surge. Crops could fail. It could be a catastrophe. Chemical companies, newspapers, and even other scientists said horrible things about Mario. Someone even accused him of being a spy trying to cause chaos in America. But why in the world would I make this up, Mario thought. I'm a scientist. He never gave up. He was going to keep at it until he got them to listen. Then, a British scientist took some measurements of ozone in the atmosphere. He found something strange. What do you think he found?
It was breaking up.
It was breaking up. There seemed to be a huge hole in the ozone over the Antarctic. A hole the size of the United States. That's huge. People wondered how that could happen. How could we have so much impact on our atmosphere and so quickly? Mario and Sherry, again, tried to explain the chemistry. Still, people demanded more proof. Scientists launched an expedition to Antarctica, counting chlorine and ozone from a high-flying airplane. The results were clear and horrifying. Chlorine was definitely destroying ozone. Finally, people believed the scientists. Something had to be done. But what? Leaders from countries all over the world flocked to Montreal, Canada, to discuss the problem. Mario explained the science. He pleaded for nations to join together to stop the destruction of the ozone layer. The discussions were so slow and cumbersome, he says. I worry they might not succeed. Representatives returned to their countries across the globe. Mario returned to his home in the United States and waited. This was the Earth's first global issue, says Mario. There really was no example of the whole planet taking action on something like this before. I didn't know what would happen. What do you think happened?
Someone believed him.
Somebody believed him. Then Mario heard the news. 28 countries, including the United States and Mexico, agreed to stop making CFCs. Soon, 46 countries agreed. Then more than 190 countries, nearly every country in the world, agreed to the Montreal Protocol. It was thrilling and satisfying and very much a relief, Mario says. For a while, CFCs already floating around in the air continued to rise to the ozone layer. But Earth slowly makes ozone all the time. Once the barrage of CFCs lessened, the ozone layer began to recover. It is expected to heal completely by 2070, but we're doing really good. It started to heal a lot already. Humans had created the first global environmental problem, and they found a way to fix it. He was so happy. Now, when Mario visits his hometown of Mexico City, where pollution clouds his view of a snow-capped volcano, he worries about another invisible problem: global warming. The burning of oil, coal, and gas is changing the world's climate at a terrifying pace. But Mario has hope for our planet. His work on the ozone layer has shown that nations together can solve global problems. We can work with all countries, all cultures, all people of the world. He says, we can work together. It is possible. We saved our planet once. We can do it again. And here's the story. Mario takes on global warming. This is the facts. On October 11th, 1995, Mario Molina was in his office preparing to teach chemistry class. Bring! The call was from Sweden. Mario, Sherry Rowland, and the atmospheric scientist Paul J. Crutzen had won the Nobel Prize in Chemistry for their work on CFCs and the ozone layer. I was just stunned. I was just so surprised I couldn't believe it. Mario recalls. Mario's students celebrated by serenading him with a mariachi band. I slowly realized that winning the Nobel Prize and all the attention one gets, I could put that to good use, he says, and he has. Mario has donated $200,000 of his Nobel Prize money to the Massachusetts Institute of Technology for a fellowship program for young scientists from developing countries. You never know which young, bright mind holds the solution to a serious problem we face in the world. We need everyone. Then he turned his attention to another big environmental problem, global warming. Scientists had discovered that the burning of fossil fuels such as coal, oil, and natural gas were releasing greenhouse gases into the atmosphere. These gases trap heat, warming the planet and causing global climate change. The more Mario learned, the clearer it became. The world is warming at a dangerous rate, and human actions are to blame. True, replacing fossil fuels is more difficult than replacing CFCs. But we do have solutions, Mario said. What we need is for most of the countries to agree, just like they did with the ozone layer, that the problem is so serious that we have to solve it using everything in our power. Mario has gathered with other scientists, urging the world to act quickly to prevent further global warming. They have advised the U.S. Supreme Court to support regulation of carbon dioxide emissions from cars. And Mario has counseled presidents of the United States and Mexico on environmental policy, encouraging them to participate in the first international effort to slow global warming. In 2016, the world began to address the problem. As part of the Paris Agreement, 195 nations promised to reduce carbon emissions. The goal is to keep global temperature changes under 2 degrees Celsius. Mexico promised a 25% drop in carbon emissions by 2030. The United States has pledged to reduce greenhouse emissions from 26 to 28% by 2025. And President Barack Obama followed up with efforts to support clean power and curtail tailpipe emissions. Mario and fellow scientists call the agreement a small but historic vital first step towards a more enlightened stewardship of Earth's climate systems. But President Donald Trump, who has repeatedly called climate change a hoax, intends to withdraw from the Paris Agreement as soon as the agreement allows. Withdrawal would become official in November 2020. Mario and 29 other scientists advised the Trump administration against withdrawal. Most of the climate warming over at least the last 6 decades has been due to the burning of fossil fuels and other human activities, they wrote. If we continue to increase the atmospheric levels of greenhouse gases, the Earth will continue to heat up, with serious consequences for economies and ecosystems across the globe. But they rang a note of hope. Just as science has diagnosed the causes of changes in the Earth's climate system, science can also provide the basis for solutions, they said. Many citizens in the United States are not waiting for federal government to take needed steps. Thousands of state governors, city mayors, and business CEOs have promised to keep working to meet the Paris Agreement carbon emission targets. We fix the ozone crisis. We can end global warming too. But we need to commit to solving the problem together. Climate change is perhaps the most worrisome global environmental problem confronting human society today. Mario Molina, speaking before the U.S. Senate Committee on Energy and Natural Resources.